Welcome to the Live Safety Demos. My name is Matt Hollowell and I'm a professor at the University of Colorado. I'm excited to share with you our first live safety demo. A recent analysis of injuries in industrial construction has revealed that over 20% are caused by falling objects. Furthermore, nearly half of all recordable injuries involve the hand as the injured body part. For these reasons, our first live safety demo involves a sharp falling object striking a hand.
Here is an example of an actual injury that we are going to simulate. Unfortunately, these types of injuries are all too common. One of the most important aspects of this project is to replicate injuries as accurately as possible. Keeping in mind that these are meant to be hands-on demonstrations, we focused on creating an incredibly realistic replica of a human hand. This table shows a comparison between our fabricated hand and a real human hand. In addition to the flesh properties, the hand also contains acrylic bones and a blood network that includes a radial artery and central arteries under 2 pounds per square inch of pressure, the same as blood pressure. Let's visit the science behind dropped objects to better understand why injuries occur to the hand when they are hit by falling objects. We are all familiar with gravity as the reason why objects fall toward the earth. Gravity is a long-range attractive force between two objects with mass. Whether it's rain, snow, or an apple on a tree, all objects are attracted to the Earth's surface. Calculating the force of a falling object and determining its potential to injure a person requires a little bit of math and science. An object with mass has potential energy when it is positioned above the Earth's surface. When the object is located at maximum height, its potential energy is equal to the mass of the object multiplied by the height and the gravitational constant. An object at height poses no risk unless the energy is released, allowing an object to fall. When an object falls, all of the potential energy is converted into velocity, otherwise known as kinetic energy. The velocity increases as the object falls, reaching its maximum speed right at the point of impact. At this point, all of the potential energy has been converted to speed. The injury that our sleeping man would sustain depends on the force that an apple would exert on him when it strikes. The force depends on the potential energy before the drop. Even more, the force depends on the distance that the object travels before it comes to a stop. If a stuntman is allowed to free fall on a concrete floor, he will be severely injured from even a modest height. However, if an airbag is placed below him, he can fall safely. The difference is the distance that the object travels as it decelerates, seen here as s. This is the work energy principle. Let's see how this applies to our live demo where we have two workers. One is using a 1 kilogram concrete chisel on an elevated platform and the other is working 10 feet below. The injuries sustained should be related to the mass of the object, its height, and the distance of deceleration, right? Well, close. There's one more factor to consider. All else kept equal, there's a reason that a chisel is more dangerous than other objects. This reason? A chisel has a very sharp point. A book, on the other hand, has a relatively large area of contact. Even if the force exerted by the two objects is the same, the chisel will cause greater damage because of a dramatic difference in the pressure exerted by the two objects. Pressure is equal to force divided by area. In our example, the falling chisel exerts about 1,400 newtons, and the contact area is very small at 0.0003 meters squared. The result is a pressure of 49,000 kilonewtons, or just over 7,000 psi. A science book, on the other hand, exerts the same force, but only 3 psi because of the increased contact area.
Now that you know a bit about the science behind the forces and pressure of falling objects, let's see the live demo in action. Here you will see the impact of a falling concrete chisel from a height of 10 feet. We will show you the impact on a bare hand and provide a comparison with a gloved hand.
What you are about to see is a 1 kilogram chisel falling approximately 10 feet from an elevated platform. This video is recorded in real time to show the speed of the actual injury.
Go.
3, 2, 1.
What you are seeing here is the same drop occurring at approximately 1,000th the speed. As you can see, the chisel clearly goes through the hand and strikes the radial artery, which is under 2 pounds per square inch of pressure. The blood beneath the hand indicates complete penetration of the chisel. This would be classified as a disabling injury. What you are about to see here is the same concrete chisel dropping from the same height and striking a gloved hand. These impact-resistant gloves increase the contact area of the chisel to 2.5 square inches. This decreases the pressure of the chisel on the hand by 98%.
I hope that you have found this demonstration to be effective and engaging. Please join us in trying to make construction a safer and healthier workplace. Please feel free to contact us with feedback and questions at matthew.hollowell@colorado.edu.